up, squad? This is a very quick problem at the back of the circular motion. It says a cyclotron, which is a type of particle accelerator, a deuterion of mass 2.00 u reaches a final speed of 10% the speed of light while moving in a circular path of radius 0.48 meters. What magnitude of the magnetic force is required to maintain the deuteron in a circular path? So here's the cyclone. It is going in a circle, cyclotron. This is the deuteron. It has a mass of 2.00 u. What is that? Here I have the conversion. You could just Google this, or you're going to see it on an equation sheet. 1 u is equal to this many kilograms. So I just multiply this by 2, and that gives me the mass, because I like SI units. Here's the radius, 0.480 meters. And here is 10% the speed of light. Speed of light is 300 million meters per second. So 10% is 30 million meters per second. We're looking for the magnitude of the magnetic force, which is keeping this thing in a circle. So it is a force. I put F. This is F equals ma, most important equation from chapter 5. This is acceleration in a circle, most important equation from chapter 6. I have A over here. I could just plug it into here. I have mass right over here. I have velocity right over here. And I have radius right over here. So I could literally just plug everything in and get an F. Is that this F? I don't know, but we're just going to plug it in and try. Here we go. F equals ma. We replace this. We put this in kilograms. We multiply this meters per second squared, 10% the speed of light in meters per second, because it's a squared. Here we have 0.480 meters, and I plug it and I get this answer, and this is the right answer. How do we get newtons? Check out what are the units in here. Kilograms, meters per second squared, meters. So kilograms, meters per second squared, meters. These are the units. How do you convert this to newtons? If you just remember F equals ma, you could see that F with units of newtons is equal to m with units of kilograms times a, which is meters per second squared. So that is what 1 Newton is. It is these units, kilograms times meters over second squared. Over here we have meters squared over meters. So one of these cancels. So the square is only applied to the seconds. Kilograms times meters over seconds squared, kilograms times meters over seconds squared. So I can put the final units over here. This is a quick problem. As you guys can see, it was just plug and chug. Try this out. If I do this, I am now armed for problems of this nature on the midterm exam, and go through the back of the book and go through any problem that you find that you think is interesting. Good luck, guys. Let me know if you have any questions that I can help out with.